Imagine a place far beneath our feet. A place 100 miles down, deep within the Earth's mantle. Here, the weight of the world creates unimaginable pressure. The heat is immense, a slow and silent furnace that has burned for aeons. In this crucible, simple carbon atoms were crushed together with a force beyond our comprehension. This immense power, acting over billions of years, began a quiet transformation. It was here, in this fiery darkness, that something extraordinary was born. A substance of perfect clarity and strength, a message from the deep earth. At its core, a diamond is surprisingly simple. It is made of a single element, carbon. This is the same element that forms coal. This is the same element that forms the graphite in a pencil. Yet, the arrangement of its atoms makes all the difference. Deep within the earth, under intense heat and pressure, carbon atoms lock into a perfectly ordered, incredibly strong crystal lattice. This structure gives the diamond its unique and remarkable properties. The same ingredients, different conditions, produce vastly different results. The ancient Greeks encountered this substance and were astonished by its resilience. They named it Adamas, unbreakable, invincible. On the mineral hardness scale devised to measure resistance to scratching, the diamond sits alone at the very top. It is the hardest natural material known to us. Because of this hardness, a diamond can cut or grind any other substance. Yet it can only be scratched by another diamond. It is nature's ultimate tool. Internal perfection is what gives the diamond its famous fire. When light enters the crystal, it is bent and split into the colors of the rainbow. The human story with diamonds began in the riverbeds of India, perhaps 4,000 years ago. There, glinting amongst the sand and gravel, were the first of these stones to be discovered. For centuries, India was the world's only source. These gems were not yet symbols of romantic love. They were talismans of power, wealth, and divine protection. They adorned the statues of gods in temples, the crowns of kings, maharajas. They were believed to bestow strength and courage upon their owners. As explorers and traders began to connect the world, these Indian diamonds started their journey westward. They found their way into the treasuries of European monarchs and the collections of the wealthy. The allure of these stones grew, and with it, the desire to find more. The search expanded across the globe, leading to discoveries in Brazil, and then, in the late 19th century, to the vast diamond fields of South Africa. This changed everything. Suddenly, diamonds were more accessible, and great mines were established in places like Botswana, and more recently, the remote tundra of Canada. This global journey produced some stones of legendary size and fame. One such stone is the Cullinan diamond, discovered in South Africa in 1905. It was the largest gem-quality rough diamond ever found, weighing an astonishing 3,106 carats. It was so magnificent that it was eventually cut into several major stones, many of which now form part of the British Crown jewels. While we often think of diamonds in terms of jewelry, their greatest impact on our modern world is far less glamorous. Today, a remarkable 80% of all mined diamonds are not destined for a ring or a necklace. They are put to work. Because of their supreme hardness, these industrial-grade diamonds are essential tools for shaping our world. They are embedded in the tips of drills that cut through solid rock, and in saws that slice through concrete and steel. They make precision and power possible in the most demanding environments. The unique properties of diamonds have also found a home in the world of high technology. Their ability to withstand extreme heat and conduct it away makes them valuable in electronics and computing. In medicine, surgeons can use scalpels with microscopic diamond blades for incredibly precise incisions. Lasers that use diamond components can operate at higher powers and with greater stability. Furthermore, we no longer rely solely on the Earth for these remarkable crystals. Scientists in laboratories have learned to replicate the conditions of the deep mantle. Using high pressure and high temperature, they can now grow diamonds in a matter of weeks or months. These lab-grown diamonds are physically and chemically identical to their natural counterparts. They provide a sustainable and ethical source for both industry and jewelry, a testament to human ingenuity and our ever-deepening understanding of the natural world. The story does not even end on our planet. Far out in space, in the constellation of Centaurus, there is a dying star, a white dwarf catalogued as BPM 37093. Astronomers have studied its pulsations and concluded that its core has crystallized. It is, in essence, a diamond of cosmic proportions, 10 billion trillion carats in size. They have affectionately nicknamed this star Lucy. Why do we value them? Perhaps a mix of human storytelling and the incredible endurance of nature. Sparkle meeting survival, reminding us what lasts. Born of fire and pressure, a diamond becomes light, formed over 3 billion years ago, deep within the earth. We prize them for beauty and the endurance they embody.